We want to find the center, vertices, foci, equations of asymptotes, and graph this hyperbola that's given. As we look at the equation of the hyperbola, we see that the y squared term is positive and it's first. So the version we need of the formula is the second one. And we can find the center. It will be at HK. And be careful, because if the y squared term is first, remember if you looked at that first term, you'll get y equal 2. That's the y value of the center. And then if we do the opposite of what is here, we'll get the x value of the center will be -3. So I'm going to find that center, -3 and up 2, and I'm going to put an x there because that's where I'm going to measure from as I figure out this hyperbola. All right, the next thing I'm going to do is I'm going to look at this and see that underneath the y term is always our b squared. So we know that b will equal 3. So from the center, I'm going to go 3 up, and that will be one vertex. From the center, I'm going to go 3 down, and that will be the other vertex. So I've got my 2 vertices. And those vertices are at the x value of -3, and from the center value of 2, if I add 3, I'll be up at 5, and if I take that center value of 2 and I subtract 3, I'll be down at -1. You can see that's where those vertices are. Okay, the next thing I'm going to do is look at a squared, which is underneath the x squared. And a squared is 4, so that means a equal 2. So from the center, I'm going to go 2 each direction for the x. I'm going to go to the right 2, and I'm going to go to the left 2. Those lines now define my guide rectangle. I'm going to add in my guide rectangle, then a rectangle that has the center at the center, and it goes through those points. I went a little too far right there. There we go. Now I'm going to draw the diagonals of that guide rectangle. They go through the center and put on the diagonals of that rectangle, and these are the asymptotes for this hyperbola. I have enough info then I can go ahead and graph the hyperbola. It's going to go through the vertex and head towards the asymptote. So the transverse axis here is parallel to the y-axis, as we see, and there is my hyperbola graphed. Now I'm going to answer the other things it asked. It asks for the foci. The foci are located inside each branch of the hyperbola, and they are c away from the center. So let's go ahead and find the foci. And the connection is c squared equals a squared plus b squared. And a squared was 4 and b squared was 9. So c is going to be the square root of 13. So from the center, I move up the square root of 13, which is about 3.6, and make a focus. And then from the center, I go down that same square root of 13 and make the other focus. So listing the foci, I stay on the same x value of -3. I start at the center of 5, and I add square root of 13. And that was my first focus. And then staying on x equal -3 and the y value of 5, I go down square root of 13. So minus square root of 13. And there's my other focus. Last thing we need are the equations of the asymptotes. So to find those equations, I'm going to use the point slope formula for a line. Y minus the y from the point equals the slope times x minus the x from the point. And the point on both of those asymptotes is that center point. And so I do know that point, the center is at -3, 2. So that's -3 and 2 is a point on those asymptotes. And they will have the same slope except opposite signs. One's a positive slope, one's a negative slope. So I'm going to go from the center, and I need to go up 1, 2, 3. So the change in y is 3, and I need to go over 1, 2. the change in x is 2. So my slope is going to be 3 over 2. And let's see, let me put in, though, this should be y minus the y from the point. And then there's my slope. And then I've got x minus a minus will make it a plus, the x from the point. So there is the equation of my first asymptote. And my second asymptote is the very same equation, but with a minus. So I could fit them both. Since I'm about out of room on this slide, I'm going to put a plus minus. If you were entering them in a computer, you'd do the positive one and then the negative one. And the form that they usually leave them in is they solve for y. So plus or minus 3/2 x plus 3 and then plus 2 on the end, because we're going to move that over so that the y is by itself. So there's the equations of the asymptotes.